And welcome again. This time we have a different kind of problem. This is a simple circuit, only two capacitors and one battery is involved. And if we can see the problem, we have something like that: two capacitors with capacitances 2 microfarad and 3 microfarad, C1 and C2, are connected in series. I can see them and hooked up to a battery with EMF equals 120 volt. That's also true. Whose midpoint is grounded. That means this battery holds this one holds 60 volt and this one also 61. So total becomes equal to 120 volt. Whose midpoint is grounded. Okay, the wire connecting the wires can also be grounded with a switch. Here something switch. Find the charges Q1, Q2 and Q3 that pass in the indicated directions through the cross section. 1 that is Q1, 2 that is Q2 and Q3 here. Okay, so this is the problem, and switch is open right now, and I can see that the capacitors are connected in series, so charges of them are equal before the switch is closed, of course. And I can write this charge equal to C1 C2 by C1 plus C2 multiplied by the potential difference supplied by the battery, whole of the battery. And this is my equation 1. And I can see that after the switch was closed, or switch is closed, the voltage across each capacitor becomes E by 2, because these two are same points, and so these are equipotentials. And after the switch is closed, the voltage across each capacitor becomes simply E by 2, that is 60 volt. So their charges become, suppose that the charge on C1 becomes Q dash, and Q dash is now C1 E by 2, and Q double dash, the charge on capacitor C2, is now C2 E by 2, and simply we need to find charge Q1 that passes through the region 1 and so I can write Q1 equals simply as Q dash minus Q, nothing else. And Q dash minus Q will, of course, you can calculate this. It is going to become C1 minus C2 divided by 2 C1 plus C2. I already calculated this E, and that is equal to minus 2.4 into 10 to the power minus 5 coulomb. And so the negative charge flows in this direction, and its amount is equal to minus 2.4 into 10 to the power minus 5 coulomb, or you can say a positive charge passed in this direction of the same amount, 2.4 into 10 to the power minus 5 coulomb, or like that. In the simpler manner, charge passing through Q2, it can be written as Q minus Q double dash. Why? First was Q minus Q dash, and second we can write as Q minus Q double dash. Why? Because it has previously got the charge Q, and now it has charge Q dash, and it has previous charge previous charge Q, C1 got the previously got the charge C1 previously got the charge Q, and finally as Q dash. So Q1 passed through in this direction as Q dash minus Q. And why we are writing that charge in this direction through the Q2 will be Q minus Q double dash, because you can say that Q came on this charge Q2 in this direction Q, and Q dash through also through this direction. So in this direction the charge has gone equal to Q final charge minus initial, that is Q double dash minus Q. So in this direction we are going to write is Q minus Q double dash, and you will find this charge, and it will also come negative minus 3.6 into 10 to the power minus 5 coulomb, and you can write them you can interpret them as you wish. And the total charge on the interconnected plates of the capacitor, this one after the switch is being closed, was initially 0 because nothing passed through it. Before the switch was closed, nothing passed through it, the part third, before the switch was closed. While after closing it, charge Q double dash minus Q dash is passing in this direction, and obviously this comes from this. So you can write here that Q3 is going to be Q double dash minus Q dash, and you can get your values as 6 multiplied by 10 to the power minus 5 coulomb as well. So that's it. Or you can simply write like charge Q3 came in this direction and Q dash came in this direction, and Q3 Q double dash passes like this. And if you can use the principle of conservation of charges, you can write here incoming charges, that is Q dash plus Q3 is equal to outgoing charges from this point, and that is Q double dash. And you can also write that Q3 is equal to Q double dash minus Q dash, and that was our point. The difference is how can you see it, but you can see from different perspectives. Thank you very much for watching.